All right, today what we're going to do is we're going to actually describe some of the commands on a CNC program for a lathe. Keep in mind the lathe is a 2-axis machine. X-axis is on diameter. Remember that's OD, outer diameter. And then Z-axis is your length on the part. So I'm going to go through here on the control, and one of the ways of running the machine is called single block, which means it's going to execute a single line as part of the program. So let me get started, and I won't explain all of the program, but I will explain the majority of it. All right, so anytime you see a program number, that's so you can keep track of the program by the part number or by the program number that you want to call it, so you can actually find it. Anything that's in a parentheses is called a man-readable, which means it's manually able to be read. In other words, it's a explanation of what that particular part of the program is or what this part is. Anything that you want as an explanation to you as the programmer or the operator. So here it's saying that we have a 5/16 radius. Now here what we have is I call it dwell. This is a macro, 9150. The 9000 series are macros in the machine. So what that does is it's high-level programming to just accomplish getting through the program, holding the part, and it actually says call it dwell. That means it's going to stay for a certain length of time to make sure it's closed. Okay, so now we're going to get into X and Z dimensions, and then we're going to get into offsets. When you see G0, that's usually a rapid movement. When you learn programming, they'll say go. G0 versus G01. G01 is a linear movement with a feed rate. So T0, anything with a T is your tool, like your tool command or your offset. T0 means you're going to cancel your offsets. Now we're going to go to Z 3 inches. We're establishing the face of the part as being Z0 on a grid. If the number's positive in Z, it's going to be away from that. If the number's negative, it's going to be towards that. MO1 is an option stop or a program stop. I believe M00 is program stop and MO1 is option stop. Anytime you see an N command, that's an operation. That's so you can sequence things for the different operations in the program. In this case, we're going to spot drill. Okay, the G97 is a preparatory command for spindle, turning the spindle on. M3 means turn on and forward. If you wanted the coolant on, we're running brass, so we're not running coolant, it would be M13. If you wanted to run it in reverse, it would be M4 or M14. M4 without coolant, M14 with coolant. S2000 means it's at 2000 revolutions per minute. Now we're going to go and we're going to X of 0. So we're going to, with the offset is T10 on this particular tool. So it's going to pick up that geometric offset where it is and stay right there because we have X0. So we're not going to go off of that. Then we're going to go to 100 thousandths 0.1, which is a positive number in front of the part. And then we're going to feed in Z dimension of negative 200 thousandths at 3 thousandths inches per rev. That means we're going to move so many inches, in this case 3 thousandths per revolution as the spindle is rotating. Then we're going to go G0, 1 inch. Positive number from the face of the part. Option stop. Now we're going to go with the drill. Once again, 2000 RPM. Now we're going to go to T11, a different tool. X0, so that's the location that it's at on the top plate. Offset 11. 100 thousandths in Z position, which is in front of the part because it's a positive number. Now we're going to go Z 670 thousandths, a negative number, which means into the part at 5 thousandths inches per rev. Now we're going to go 1 inch off, and we're lowering down to 250 RPM. Once again, option stop. Now we're going into our tapping routine. Now we're going up, spindle direction and forward, 300 RPM, so we're going up 50 RPM. We're going to T12, X0 means the position that the offset states. And now we're going to go 200 thousandths in front of the part, positive dimension. And now we're going to go into a tapping operation, which is a G32, 400 thousandths at 36 thousandths inches per rev. And then we're going to come out 100 thousandths, option stop. Actually, pardon me, that was 1 inch, not 100 thousandths. By the way, as a programmer or an operator, you don't want to miss your decimal place. If you put in 100 thousandths and you put in 1 inch, you're going to have a crash. Then you need one of our service people. Here's your man readables. Once again, 2,000 RPM. Forward direction. We're going over to T14. Now we're going to go off of that by 725 thousandths. We're going to Z0, which is, once again, the face of the part. Now we're going to go to X 300 thousandths at 5 thousandths inches per rev. Then to 386 7/10. Now we're going to do a radius move in X and Z simultaneously. Okay, so now the operation that we're going to step through in single block is a cutoff operation. We're running in forward at 2,000 RPM. We're going to go to T15, means offset 15, and we're going to go 725 thousandths off of the position that it has. So now we're going to go down to 470 thousandths in Z. So we're in position now to cut off. We're 470 thousandths in the negative position. We're going to extend M26. M codes are miscellaneous functions. In this case, M26 is the parts catcher. Now we're going to go to negative 450 thousandths in X, which is right around where we need to start cutting off at 6 thousandths inches per rev feed rate. Now we went to 375 thousandths. Then we went to 300 thousandths, and as you could probably hear, the ID, the wall, we went through the wall to where we cut it off, and it dropped into the parts catcher. Now we're probably cleaning up that face. Now we're going to go out to a larger diameter, and MO5, I believe that's spindle stop, and I think you heard that. We're going to retract the parts catcher, M25. We're going to go to 100 thousandths in positive direction in front of the part or the bar stock. Now we're going to go cancel our offsets, T0. We're going to go 3 inches out, so we're really getting away from the part. Option stop. Now we have a man readable that says feed stock. So now before we shut down the program, so to speak, or rewind the program, we're going to put a stop so that the bar stock can come out to a position. MO5. Now we're going to T9, offset 9, that position that's wherever it is, X0. We got a ways to go, as you can see. So we're going clear over on the other side of the plate. Now we're going to go Z 80 thousandths off where the part is. And now we're going to open the collet, M21. And now the collet's open so that the bar stock can come out to a position. So that's to try to demystify what CNC programming is. In summary, it's preparatory codes that are called G codes. Commands like S for spindle, T for turret station or tool. M codes that are miscellaneous functions like opening and closing things or turning things on and off. And then X and Z dimensions. Because it's a 2-axis machine, remember we said X is in diameter and Z is on length. It's just a matter of a grid in math. And it's not overly difficult math, but it is math. So if you're good in math, great. If you have some difficulties in math, it's not so difficult that you can't figure it out because it's really just points in space on a grid.